Oh, wait.
Let's see. I heard it's like 2.5 hours of work. She's saying there's like 30.
So let's go take it.
Should I just go home? Yeah, I'd rather just go home. Did you take it?
Where are you taking the
Give me these.
Bro, I was in comp too. That's right.
Oh, really? So just doing 22 seconds measure.
Wait, say bonus?
But if you collaborate, then you have to split your grade. So
See what she tells me. Thanks for the golf lesson.
Golf lesson?
He was playing Mario Golf when it was Crump Parent Advisory.
There's the math way to do it.
I miss Polar. I like this.
What is that for polar?
I'm
Which
just
one?
thinking out loud.
Which one?
Mario Golf 64.
Oh, good.
He knows some website you can play that. So I was messing with him on Go Guardian. I blocked him.
So are we getting sea lunch?
No. It's only 10 questions.
What if it takes the whole time though?
That's fine. It can take you the whole time.
So can I come back after lunch and finish? Could I have to
No.
wait during lunch?
You won't need that. It's like 4.5 minutes per question, and you can start right now if you want. Once you put your stuff away, Landon, here's your page.
I forgot. I just tried it.
How do you know I did it?
I read it 15 minutes ago. Oh, okay. That's like the useless one. Mine can only drink. Yeah. Sorry, actually.
When you're ready? Just go. Okay, good morning. Make sure I had your review before you get going on your quiz too much here. Quiz this morning is no calculator. And I don't think you will feel as pressed for time as you were on the Polar one. This one is a total of 10 questions. and they're all multiple choice, 2 points apiece. Of course, some of these are pretty quick, and some of them take a little bit more thought, but you have the whole first half of class to worry about that stuff. And I do have a handout for you for after lunch, so after you turn your quiz in, if you would pick that up at the door, or at least get it when you come in from lunch, I'd appreciate it.
Did y'all get that email yesterday about the whooping cough?
About what?
Whooping cough?
I don't think so.
Oh.
Check right now.
It was yesterday. You would have seen it by now, probably. Some elementary kid, I think, has whooping cough, but it's like very contagious, I think. It's kind of
No,
scary.
I got it. I just missed it.
Olivia, you not participating today?
Well, I know I got one question wrong in the first part, first 7.
How do you figure it out after the fact?
I asked somebody.
Theirs could have been slightly different. If they had a different form, I could have just changed like a negative sign or something.
Well, no, I mean like they had the actual like the same book. I told them like the question type, and apparently that's supposed to be like use substitution or something. But I couldn't find that. Yeah, no, it really did not look like a use substitution. So that's just my fault.
We need a girl in there. So now what's your plan? Oh, you don't have a dog yet? So I probably need to do that.
Is Denny gonna make it on time? Probably not. I'll just count him tardy now.
Maybe Danny ran away. He's not scared about the test.
Don't get my hopes up. Okay?
Has the, no, I think that was done. I for sure had it.
I think
You do need this handout up here. If you forgot to grab it on the way in, please go get it. Now, this is a little bit longer of a handout, so this is not one that you will need to have finished by Tuesday of next week, but we need to go ahead and start it here. So, 10.6, we start talking about comparison tests. So I kind of warned you about this, specifically the P-series and geometric series. We are going to make references to those and use what we know about when those converge and diverge to help us branch out and do more infinite series and figure out if they converge or diverge. Sorry, I have to erase my work from my last class. I don't have 2 copies of this. Okay, so go ahead and number this as 42, please. Yep. 42, and then, so the first thing I need you to realize before we dive into this is there's 2 different tests here, so make sure you're paying attention. For a minute, we're going to talk about the comparison test. So I'm going to tell you what that says. This one's the more intuitive. And then we do a couple of examples of that. And then completely separate, we're going to talk about something called the limit comparison test, which is not as intuitive, but has a process that works. So, all right. You guys ready?
Well, yeah, Olivia had a question to ask you first.
Yes, what's your question?
Do you want to know what your favorite season is?
My favorite season? I'd say normally this season, fall. But why? Because the temperature's nice, it's pretty outside.
I also agree. Fall is my favorite season.
I don't like fall.
I think everyone should go around and say their answer.
I don't like fall because it's.
Okay, everybody say your favorite season in 3, 2,
Oh, no, like
1.
one at a time.
Oh.
Wait, I don't.
No, because now you're trying to delay
I like
the
summer.
Yeah, my birthday is in the summer.
You
so
missed.
like that.
I asked already. We're
Yeah.
moving on.
Well, I didn't get to explain why.
Oh, but yeah, wise for next time. Okay, so the comparison test. First off, make sure you pay attention to this. We've got A sub n and B sub n. So A sub n is the sequence given to you in the question. So this is the given sequence. Whereas B, when we talk about B sub n, this is what we are going to use to compare to. So we are going to compare it to another sequence. Now, again, make sure you understand this one because what I'm about to say is either going to make sense to you or it's not, but there's lots of conceptual pieces here. If this is true, if we know A sub n is less than or equal to B sub n, and let's say the infinite series of B sub n converges, if B sub n is converging and A sub n is smaller than that, that means he has to converge also. That should make sense because it's like if here's B sub n and it's approaching a number and A sub n is even less than it, it also has to be approaching a number. Okay, whereas if A sub n diverges, notice they're switching this, so if this goes to infinity and B sub n is bigger, then it has to go to infinity also, and if they're both going to infinity, then they're both diverging. So basically, if you know something diverges and you are sure your question's bigger than it, then you can guarantee that it diverges also. If you are sure that something converges and your question is less than it, then you can be sure that it converges too. And so that's it. So what we would do is, this looks similar to what we've been doing, but just a tiny bit different. You have to start to try to figure out, well, I think it'd be good if you label, this is A sub n, B sub n is what we're going to try to compare it to, and this honestly can be the most challenging part. This is the most uncomfortable part, trying to guess what to compare it to. So really when you want to compare it to something, you're really trying to focus on the most important things. When you're plugging in really big values of n, this plus 3 does nothing, or next to nothing. It's either, if this goes to infinity, adding 3 to the denominator is still going to go to infinity. If this is going to 7, adding 3 to the denominator is not going to change that it converges. So what's the important part here is 1 over 2 to the n, which is the same thing as 1/2 to the n. And this should be familiar to you because this is what type of series?
Geometric.
And I really think you need to make a habit out of doing what I'm about to do here. Even though you should recognize this as geometric, you should be able to tell me that r is 1/2. Because the absolute value of r is less than 1, we know it converges or diverges. Converges. I really feel like if you make yourself write that every time, it's geometric, this is r, because r is this, it converges. You're going to just keep getting that reinforcement of geometric works this way, p-series works that way, etc. Okay, so I know the thing that I'm comparing it to converges. How does this, how does this compare to, I'm going to swap these two around. If I make my denominator bigger, does that make my fraction bigger or smaller? Smaller. So if this converges and this is less than it, he has to converge also. Again, remember, converge means it settles to a number. So I could figure out what number this settles to, by the way, because it's geometric. But if this settles to 7 and this is less than that, then we can at least know that he is going to converge also. So if your question is less than something you can compare it to that converges, then your answer converges. Okay, and now here's an example of where this can be frustrating at times. So you saw that example, you saw what I picked out b sub n to be, what I want to compare it to, and so I would assume if I asked you what you think b sub n should be in number 2, a lot of people are going to guess 1 over 4 to the n, which is the same thing as 1/4 to the n. And you can go through this and you can say, all right, this is geometric, r is a fourth, absolute value of r is less than 1, so I know this converges. Everything seems fine right now. But now I need to compare this that I know the answer to this that I'm trying to find the answer to. Okay, if I make my denominator smaller by subtracting 3, does that make your fraction bigger or smaller?
It makes your fraction smaller.
If you make the denominator smaller,
Yeah.
is 1/2 bigger or 1/3?
Wait, no. It's
Yeah, you got it the other way. If you make the denominator smaller, you're making your fraction bigger. That's a problem. That's not good. If this converges, I only know this converges if this is less than this. If it's, this might go to 7. If this is bigger, I can't guarantee that it's 8 or 10. It might go to infinity. So the problem is, because this wasn't the right size, when we compare these, this one was less than this, not the other way around. This just didn't work as a comparison. Now, when I redid this the other day, like I usually do a few days before our class, that's what I picked out for my comparison as well, and I did all of this, and then I realized, all right, that didn't work, so I have to try something else. So you can really compare it to anything you want to, but what I did is I tried comparing it to 1 over 3 to the n. And what made me think of that is I knew if it's 1 over 3 to the n, it's geometric, that converges. And then now how do these two compare? Which one of these denominators is going to be bigger?
the right is going to be bigger. Or no, the left is going to be bigger.
Okay, wait. And I don't remember my question. Are we talking about the denominator or the entire fraction?
The denominator is going to be bigger on the left.
The denominator is going to be bigger on the left, which means its fraction is smaller. The bigger you make a denominator, the smaller your fraction gets. 1/10 is a lot smaller than 1/2. So now that I know this converges, and now this is less than it, now I can confidently say it converges. If your question is less than something converges, it converges. If your question is bigger than something that diverges, it diverges. If it's something in between, we don't know. It could do anything.
Wait, what's stopping us from comparing it to like something obscenely big?
Such as what?
Well, I mean, like, say we have like one thing that's super big, but like, what if we compare it to something that's super big? Like something that's bigger.
If it's something that you know, if it's something you can figure out if it converges or diverges, and you can figure out whether your answer is bigger or smaller than what you're working with, then it's fine. There's nothing special about one over 3 to the n. You could have done 1 over 2 to the n, and it would have been the same exact result. I was just showing you that 1 over 4 to the n is a very reasonable guess. It just wasn't helpful, because it is only helpful if this converges. This has to be less than this before you can say it converges. If it's bigger than something that converges, we don't know that it doesn't diverge, because it could be going to infinity. Okay, but most of the time it's not really going to be that tricky. So when you look at question 3, what do you think is the important parts of question 3? When you're talking about really big values of n, what's going to matter?
1 over 7 to the squared.
What squared? N squared?
7n squared.
Okay, I'm going to go even further and say the 7 doesn't matter much either.
Okay.
Timesing by 7 obviously makes it bigger, but when you're talking about n values of 20 trillion, that times 7 just isn't making that big of a difference. Okay, so this is what I think will compare well. What type of series is this?
P-series.
It's a p-series where p is 2, and since 2 is bigger than 1, that means it converges or diverges? Converges. So I hope, I'm not putting any thought into this, but I'm hoping that this compared to this, do I want this to be bigger or smaller than that? What am I hoping for?
You're hoping it's smaller.
I want this to be smaller if possible. Because if this converges, I only know this converges if it's smaller. If it's bigger, then I don't know it converges. It could be doing converging or diverging. It's got to be smaller to make sure it's not going to infinity. So we look at these. This is an n squared. This is an n squared. Times this by 7 is going to make the denominator bigger. Adding 4 is going to make the denominator bigger. If you make the denominator bigger, it makes your fraction smaller. This is less than something that converges. Therefore, this converges too. And again, the hard part here a lot of times is picking what to compare it to. So over time, one of the ways is trying to think about the stuff that's important. 1 over n squared is going to be important. Plus 4 is insignificant. Even times 7 is pretty insignificant. But you want to compare it to the thing that is kind of like the highlights of that question. Okay, so we will practice some of this today, but before I show you the limit comparison test, which is a completely different test, is there anything you want to ask or summarize about 1, 2, or 3?
I wonder why they didn't give us any examples of it diverging.
I don't know, but we will certainly see that on the next page, so we won't go very long without it. Actually, I take that back. The next page has a lot more practice. It's on this. This one is less intuitive. Again, to me, the other one's intuitive, maybe a little bit because I've heard it a million times. But if I compare it to something that converges and it's less than, it converges. If I compare it to something that diverges, if it's bigger, it diverges. Anything else is inconclusive. Okay, the limit comparison test, so not the comparison test, but the limit comparison test. If the series given to you is positive and what you're going to compare it to is positive, you can divide those things, their question or their series divided by your series, take the limit as n goes to infinity, and if you get a number that is both finite and positive, then both your question and the thing you're comparing it to will both diverge or both converge. So again, it's a comparison test. We're going to pick something that we know the answer to so that we can compare it to the question given to us, and we're going to leverage that to be able to answer new questions. So we've got 6 of these. And again, notice it doesn't matter what the number is as long as the number is positive and finite. Finite is like a number you could count to if you had enough time, not infinity. Infinity is not finite. 10 million is finite because you could count to it eventually. Sorry, I have to erase my work from my other class. Okay, so questions 4 through 9, we are going to do this limit comparison test. And again, same thing. I think after you see the process a few times, you're not going to be too worried about that. But it is sometimes challenging to figure out what your B sub n is supposed to be, what you're supposed to compare it to. Some of that will get easier with practice, but some of it you need to kind of pick up on how I'm going with some of that as well. Okay, so question 4. Now, again, to be honest, you can do the regular comparison test on this if you want to. If you think you can figure out a geometric or p-series or whatever series you want, if you can come up with something and you know it converges and you're sure this is less than this, it also converges. If you can come up with something that you're sure diverges and you're sure this is bigger than it, then it diverges. The problem is this is way more complicated. It's hard to compare something to this and know if it's bigger or smaller. So our B sub n, the thing that we will try to compare it to, is, again, we're trying to focus on the most important parts. Plus 2 doesn't really, or minus 2 basically does nothing. Plus 1 basically does nothing. Even 3 times n does nothing compared to n squareds. So, or these n squareds and n to the 5th. So if I imagine this being reduced, n squared over n to the 5th, that's like 1 over n to the 3rd. When these reduce, that is a good guess for B sub n. Now, which one of these is bigger? Is this bigger or is all of that bigger? Exactly. So don't do the comparison test, do the limit comparison test. The limit comparison test says this stuff's A sub n, what you're trying to compare it to is B sub n. You should pick a B sub n that you know the answer to. This is a P series where P is greater than 1, so this guy converges. And what we will do is we're going to take the limit as n goes to infinity of A sub n divided by B sub n. This is what's on the bottom of your front page. But dividing by B sub n is the same as multiplying by the reciprocal. Okay, and now here in about 2 seconds, I'm going to show you why I picked 1 over n to the 3rd. And if you can see why I picked that, it's going to help you make that guess in a later question. So notice if you take this n to the 3rd and try to reduce it with this n to the 5th, again, I don't really care about this stuff so much because this stuff just isn't going to change things when you're talking about really big values of n. But if I let this n to the 3rd reduce this n to the 5th, this changes it to like n squared. And now that this is n squared and this is n squared, and I want the limit as n goes to infinity, I can just put leading coefficient over leading coefficient, like we've done in the past. I could care less about this number, but I do care that it is positive and finite. And because it is positive and finite, the answer to this question is also the answer to this question. The thing I compared it to converged, therefore the original question converged. You take the limit as n approaches infinity of the original series, A sub n, divided by B sub n. If you get a positive finite number, then the answers are the same. So that sounds like I'm saying a lot there, but again, we're going to do the same process every time, so it gets easier. Okay, let's reset. And see how the next one goes. Okay, so for number 5, again, this is going to take some practice, but what do you think the most important parts of number 5 are? Because that's probably what we want to use as a comparison.
Just 1/5 n squared.
Okay, and I'm
Or
even
just n squared, yeah.
yeah, even the 5's not that important. The 1 over the n squared is the most important part there. Is this, okay, this is kind of a hard question to ask, but why is this an I don't know if it's going to work, but why is this a reasonable B sub n comparison guess? Do I know if this converges or diverges? Yes, it's P series that converges. If you find a B sub n, if you don't know if it converges or diverges, that's not helpful. We're trying to figure out if this does the same thing as this. So if you don't know if your B sub n converges or diverges, you need to pick a different B sub n. You got to pick one that you know the answer to. Okay, now, you don't necessarily have to do the limit test, the limit comparison test. We could also just try to do the comparison test. How does this compare to this?
It would be,
Which side is bigger?
yeah.
Okay, and if I know this converges and I know this is less than it, then I know it also converges. You can just use the regular comparison test. If it's less than something that you know converges, then it has to converge too. If it's bigger than something that diverges, then it has to diverge too. You don't have to do the limit comparison test. It's when you don't know which one of these two is bigger that you want to do the limit comparison test. Come on. Okay. So before we say out loud, I would like you to make a guess on your paper for B sub n. What do you think? And again, there's not one right one, but there is probably one much more efficient one. So go ahead and write down what you think, right or wrong. We can fix it if we need to. Okay. What did you guess?
1 over n square root. 1 over square root of n.
Okay, so 1 over n to the 1/2. That's what I would have guessed as well. And yes, there's technically a square root of 3 there, but multiplying by the square root of 3 is not a big deal when you're talking about numbers close to infinity. Okay, this is only an acceptable B sub n if we know if it converges or diverges. If we don't know, then it's worthless. Pick something else. But this is obviously a P series, right? That's obvious to you guys now?
Mm-hmm.
Okay, P is a half, and since a half is less than 1, that means what?
It diverges.
Diverges. Okay, so you could try to do the comparison test, and you could say this compared to this, and if you are sure that this is bigger, if your question is bigger than something that diverges, then your answer diverges as well. If you are not sure that this is bigger than this, which I am not sure, I mean, actually I'm pretty convinced that it is, but if you're not sure which is bigger, that's when you would want to do the limit comparison test. Do the limit as n goes to infinity of a sub n divided by b sub n, or multiply by the reciprocal of b sub n. And again, we always are trying to pick out things that are the important things. So when you divide by it, this cancels out the most important thing. Now the limit is 1 over the square root of 3. I could care less about that number other than it's a positive number, a finite number. Therefore, the limit comparison test tells me the answer to this question was the same as the answer to what I compared it to. So if this diverged, that has to diverge. Again, there's nothing special about the number other than it has to be positive and finite. Okay.
If we wrote it down using the other test, do we have to change it for the
Nope.
example? No.
Mm-mm. It's just, if you're gonna do just a comparison test, you can't just say this one's bigger so it converges, or this one's smaller so it converges, or this one's bigger so it diverges. Don't do that unless you're sure that it's actually bigger or smaller. Because then you might as well have just flipped a coin from the beginning. You're taking too big of a risk. Okay, I feel like picking on Janie, so what are you going to pick for B sub n?
I would pick,
It's okay if it's wrong.
1 over n to the second.
Very good. 1 over n to the second is a good guess, because n cubed divided by n to the fifth, the most important parts, reduced to this. Now again, I'm not saying this is going to work 100% of the time, but it's usually the best place to start. Okay. I'd ask Denny, but he doesn't know. Nor does this converge or diverge, and how do you know?
It converges because 2 is greater than 1 for P-series.
It's a P-series where P is 2, 2 is bigger than 1, so it converges. Good.
That's crazy shade you threw at.
That's fine, he's not listening anyway. So if this is, so since this converges, I can do the comparison test if I'm sure this one is smaller than this. Okay. Can you look at these and tell me which one's bigger?
No.
I mean, you might guess right, you might have good intuition, you might have an educated guess, but there's no point in risking it. If you're not sure which one's bigger, then we're going to do the limit comparison test. We're going to do the limit as n goes to infinity of a sub n divided by b sub n. Let this reduce, and then you're doing an infinite limit, which is basically horizontal asymptote rules. N to the third, n to the third. So this is going to go to leading coefficient over leading coefficient, 1/2. I don't care about the number 1/2. I care that it's a positive finite number, because the limit comparison test says that when you do that limit of a sub n divided by b sub n, if you get a positive finite number, then the answer to your question is the same as the answer to what you compared it to. We compared it to something that converges, therefore this converges also. Again, it doesn't mean it converges to 1/2, by the way. It just means that it would converge. All right, this is too easy for Denny, so he's going to get number 8, which is going to be one of the harder ones.
Well,
Nothing, don't worry.
I personally wouldn't let that slide, Danny.
He's too tired to fight back.
I'm just trying to instigate.
Sorry, I'm having to erase my answers so that then he can't cheat. Okay, so I'm almost 100, well, I'm very confident you're not going to pick the correct b sub n here. That's okay. But tell me what you would want to guess. Okay, so let's try 1 over n squared. Okay, and again, to be honest, when I did this the other day, that's what I picked also, because I saw n over n cubed, that reduces to 1 over n squared. And you can do that, and there's nothing wrong with this. We know this, I hope you know this converges. It's a p-series where p is greater than 1. This is where I was saying you want to be really comfortable with that, those things. I don't know how this compares to this. I'm not sure that this is less than this, so I can't just do the comparison test. I could try to do the limit comparison test. So this n squared could reduce this n cubed and leave an n. Now sure, we've got an n to the first, we've got an n to the first, but this isn't just horizontal asymptote rules because of this 3 to the n.
It would be going to infinity.
This is? Okay, well that's the problem. Infinity is not a positive finite number. So the limit comparison test is not telling us it's the same as this. It's saying that we need to try something else. So this is where Denny comes in, and instead of picking 1 over n squared, he's going to pick something else.
1.
No, something else. I really wanted, think about what's in the way. If I could get this 3 to the n to go away, then I could do horizontal asymptote rules, right? So to get this 3 to the n to go away, I need a 3 to the n over here, so this needs to be a 3 to the n. Now all of a sudden though, this is not a p-series. The only way to think of this is to think about which one grows faster. Is the numerator going to grow faster or the denominator?
It'd be the upper.
Okay, so if the numerator grows faster, then this goes to infinity, he diverges. Now that I can cancel out the 3 to the n also, I'm left with 1 n to the first over 4 n to the first. So now the limit is a positive finite number. So now the limit comparison test is telling me that this question also diverges. Again, I did not expect anyone to guess the 3 over n divided by n squared. It's good that you got the over n squared so that you could see you want these to be the same, but if there's something keeping you from getting a positive finite number like this 3 to the n, just get rid of it.
Could it just be 3 to the n?
No, because if you just did 3 to the n and you didn't have this, this would diverge, this would say n to the third, and then the limit would be 0. 0 is not positive or negative, so it's not a positive finite number. 0 is neither positive nor negative. Okay, so there's one that probably not going to work out your first try, but most of the time,
Hold on.
though, it's going to be pretty close to what you would expect. So, what is your guess for B sub n and number 9? Try to reduce out the most important parts.
It would be n over
Over, you're on the right track. N to the third, the square root of n to the third.
Square root of n to the third, yeah.
Okay, so let's write that as an exponent. And then we could subtract these. You divide things with the same base, you can subtract the exponents. So this is the same as 1 over n to the 1/2. 1 over n to the 1/2. Do we know if that converges or diverges?
It would diverge.
It's a diverging p-series. P is less than 1. And so this is one that's worth trying. Again, it just, if you don't know the answer to b sub n, there's no point in using that b sub n. We're comparing it, so if we don't know the answer, then it's a bad comparison. Okay, I have no idea how 1 over the square root of n compares to n over the square root of n cubed. I don't know which one's bigger or smaller, so I can't just do the comparison test. I can still do the limit comparison test. So, do the limit of a sub n divided by b sub n, or multiplying by the reciprocal of b sub n. Again, this is technically not equal to this, but the plus the square root of n piece just doesn't matter as much as the n to the 3 over 2 part. So we picked out a b sub n such that when we multiply this, this reduces this, leaves n's to the same power, and makes for an easy infinite limit. Because if the degrees are equal, we can just put leading coefficient over leading coefficient. And if we are left with a positive finite number, the limit comparison test tells us the answer to whether b sub n converges or diverges is also the answer to whether a sub n converges or diverges. Now, if you kind of scan the next couple pages, it's not that you don't never do this, but a lot of times these type of questions are more conceptual. You understand how the comparisons work. If one thing converges, the other thing has to converge, that type of thing.
Yes.
So what I'd like you to do, go ahead and finish copying down number 9, and then I would like you to answer 1, 2, and 3, please, on the next page. And I would like to quickly give some feedback on 1, 2, and 3. I will ask that you do a couple more questions for homework, but you do not have to finish this up for homework. We will spend more time on it next week together. What? Oh no, I didn't hear you. I was just.
I thought you just ignored me.
No, I do that sometimes. So
Really? After you was doing the thing, like I went to, I literally put +10 to it. I don't know, I had B and
That's what I have.
I didn't even get that far. Yeah. And then I was gonna skip it, but this is the one that's the one.
It's like you just. Knife is a T. I'm trying to.
Like, I looked like it was, I felt like I had a screen in front of me. Imagine if you could do that in real life.
I kind of wish I had been.
Like, you're
Piece of
away
it.
from me,
That's
you're
why I
like,
kind of wish I was like online and figured out what the limit was, and then I looked at the answers and figured out. Okay, I'm not trying to look at it.
it's like a.
This I kind of.
I feel like you do one over N.
But like that test, I don't get.
Wait, this I kind of get. But I don't really get why we're doing it.
So
I wish.
then
I
it
was
has
trying to
to
get a
be
word
these.
problem. I want a word problem.
Oh,
Well,
shit.
but that one.
Yeah, it's usually like real world applications, so you can understand, oh,
Because where are we getting
this is how I use the thing.
Well, there's nothing to apply this to.
Okay.
Like, I don't mean like that type of like hoardings, but I mean like if it's
All
wrong,
the
you
other-
just do it differently, so like, yeah, all the other tests. You can, when you're divergent, when you're like, when the comparing thing like that work and like doing it about, I would just do it.
Oh, you could feel like what I like some of the like this n to the third over n to the fourth is like a 120
Something like when it's crossing out stuff, I'm just crossing
Here,
out
I feel
random
like
things, I'm like, what? Yeah. I can just cross out this.
so the answer is 8 bottom line. I'm happy now with 5 minutes.
Okay, I wanted to go over all three of these, but we only got time to go over number one. So why I wanted to talk about question one is if you understand this comparison test, two of these answers should make no sense at all. This is the harmonic series. Does the harmonic series converge or diverge? Diverge. And how's it going to help compare and tell you anything convergent? That doesn't make sense. Since it diverges, it might help you figure out that divergence. Okay, this is a p-series. Does this converge or diverge? Converges, so there's no way, if you're comparing it to something that converges, it's not going to help you learn something divergent. So these are the only two that make sense. And which one did you pick, B or D? D. This has a smaller denominator than this, which means it has a bigger fraction. If this is going to infinity and this is bigger, then it's also going to infinity. That's why it also has to diverge. So again, that's what I said, like a lot of times it's conceptual like that, just making sure you understand.
Wait, so,
Okay, so all I'm asking is if you would please try to get through question 5 or 6. It's not a lot, but it said a week, so I won't even see you till Tuesday. So please make your brain think about this again between now and Tuesday. That's a long break.
so this is right. So this is smaller, or that is bigger?
Yeah.
Smaller.
Yeah, if it's a B week,
N is
you
bigger
can
than the natural log plus 2.
if it's a B
And
week,
if the
Saturday,
denominator is
Sunday,
bigger,
Monday, and then
your
you meet on
fraction is
Friday.
smaller.
You don't get Saturday, Sunday.
You know what the natural log graph
Saturday,
is?
Sunday, Monday, you meet on Tuesday, so that's 4 days. If it's a week, you get Saturday, Saturday.
Friday.
Natural log looks like this. Yeah, plus 2 is just going to shift it right to. But
Oh, it's
one over
sorry,
x
wait, y'all
grows
just,
faster.
it works out. I did that wrong.
No, it doesn't. It doesn't work out. When you
Back up.
okay, days you only have.
Okay, if
Have
it's
a
an
good day.
if it's an 8 week and there's a 2 day, your next 8 classes is after Friday, Saturday, Sunday, and then it's on a Monday, so 4 days. If your last 2 day class is on a Thursday, you get Friday, Saturday.